F1 as center, arc on first circle. A2 dash as radius, F1 as center, arc till second circle. A3 dash as radius, F1 as center, arc on the third circle. And last, A4 dash as radius, F1 as center, arc on the fourth point. Now mark all the points. These 4-5 points, mark it out. Join it with the smooth curve, and this is how you can draw your ellipse using arc of circle method. Now let's look at the next question, please. The next question is about drawing an involute of a square of side 25 mm. Now when it comes to involute, the involute is a polygon which converted into the string, and the string, the curve traced by this string is called an involute. Now in this problem we need to draw involute for the square which side is 25 mm. So when we convert 25 into 4, that means that string length would be 100 mm. So now we will see how we can draw involute for the square of side 25 mm. First of all, let's draw a square of side 25 mm. Square of 25 mm side. Mm side. Square, we have drawn the square. First of all, let's name this as A, B, C and D. Now extend each line, extend AD, extend CD, extend BC and extend AB line as well. Like this, extend the lines. Now very simple method, very simple method. Take radius as AB and A as center, draw a continuous arc like this. The point we have got is called P1. Take DP1 as radius, D as center, draw continuous arc like this. The point we got is called P2. Now in the next part, take C as center, CP2 as a radius, C as center, CP2 as our radius, draw a continuous arc like this. The point we got is called P3. Point we got is called P3. Take B as center, BP3, BP3 as radius, B as center, draw an continuous arc till it reaches to the line. The point we got is called P4, and when you measure this BP4 length would be exactly 100 mm. 25 into 4, which means that 100 mm would be the length. This BP4 would be 100 mm. So that means that the square is converted into string. This length is 100 mm. The square is concluded in a string by tracing curve like this. Very simple yet very effective involute. This is the involute of the square. Very easy to draw. We'll have a quick recall how we can draw the involute. Draw a square of 25 mm side. Draw a square of 25 mm side. Draw a square of 25 mm side. Name it as ABCD. Very quick recap. Extend AD line, CD line, BC line and AB line as well. Like this. Take A as center, AB as radius. Take A as center, AB as radius. Draw a continuous arc like this. Point we got called P1. DP1 as radius, D as center. We have got another point called P2. Take C as center, CP2 as radius, C as center, CP2 as radius. Like this. Point we got is called P3. Take B as center, BP3 as radius. Draw a continuous arc. Point we got is called P4. And this is how you can draw an involute to the square. Now we'll see the next problem. Our next problem is about a parabola by rectangle method having base of 100 mm and axis of 80 mm, which means that we need to draw a parabola by a rectangle method. The rectangle side would be 100 by 80 mm respectively. Now let's again see what is the terminology of the parabola in terms of how parabola looks like and what is the application of the parabola. Let's have a look at what is the terminology of the parabola. First of all, what we require to draw a parabola. A parabola is a shape which is having half ellipse kind of look. In this, what you require this two outermost point dimension. These dimension require what is the base length. What is the base length? Suppose sometimes it's 100 mm. And what is the height of the parabola? Height of the parabola is this, base from the base to height, highest point. this is 80. So this is how a parabola looks like. Base length is required and a height is required. Now what is the application of the parabola? When any sort of parabolic thing has been considered, that most of you are having a bike, motorbike. So when you look at your headlight from inside, you will see that a bulb is fitted like this, right? This is our bulb. A bulb is fitted like this. Why we are using this parabolic thing? Because when this parabolic curve is used, the rays has been straightened, so it focuses only at the one point. So that's why parabola is very much important in focusing the rays. This is the example of a headlight. Another very important example is of parabolic mirror, which is used in the solar panels, which is used in the solar system to generate the electricity. A parabolic mirror like this has been put on. This is our sun, right? Sun rays are focused on maximum area so that utilization of the sun rays can be maximum and energy produced is maximum. So these are the two major applications. This is in the solar power plant. These are the two basic applications of a parabola. Which methods are used to draw the parabola? Rectangle method, tangent method, and focus directrix method. These three methods are there. In rectangle method, we require height and base length. In tangent also same, height and base length. And in focus directrix, distance of focus and eccentricity ratio. These things are required. In exam, it has been asked that a ball has been thrown from a tree. In the exams, it has been asked that a ball has been thrown from a tree and trace the curve which is been traced by the ball. Or in some of the exams, the problem is asked like this, that a cricketer have taken the shot and what is the curve traced by that ball. So when you look at this curve, it always look like this. It always look like this. Parabolic curve will always, when a ball is passing through, it will have this kind of trajectory only. So what it have? It will have some height and distance travelled. These two major things can be a parameter to draw a parabola. Now we'll see how we can draw a parabola using rectangle method. First of all, let's write down the data given. Given data is base 100 mm, axis is 80 mm. These are the data given. Parabola by rectangle method. These are the data given. Now how we can draw this parabola using the rectangle method? First of all, we'll draw base that has been given 100 mm. So we will draw a horizontal line of 100 mm first of all. I have drawn a horizontal line of 100 mm. Let's name it as AB. What would be the center of this 100 mm? It would come as 50 mm. We will say it as point number O. Perpendicular to point number O, we will take a center line. We need to draw a 100 by 80 mm rectangle. We have got the 100 mm length. Now we need to trace this 80 mm. From point number O, we will mark a perpendicular point, and from point number B we will mark a perpendicular point 2. Taking the axis length as 80 mm, drawn line of 80 mm. Over here also drawn a line of 80 mm. Join both this line together. We have got a rectangle ABCD. We have got this rectangle ABCD. Whose base length is 100 mm and whose axis length is 80 mm.